This is Debapriyo Chakraborty from Toulouse, France, and I shall be talking about logistic regression. It's a statistical model that has been borrowed by machine learning and has many applications in that field. But in this lecture, I shall talk only about the basic form of logistical logistic regression, which would be sufficient for many applications for biomedical problems. And if you are still interested to explore further, then you can follow the links that I have provided at the end of the presentation. I assume that you already have some basic understanding about regression models, variables, etc. And with that assumption, let's begin to understand logistic regression. Before we delve into logistic regression, let's start with a biomedical question. Is there any link between blood calcium and vitamin D to osteoporosis? That would be our biomedical question. If I am given this problem, then I would first get data on serum calcium and vitamin D from people with osteoporosis, and then also from people who are asymptomatic, that is, who do not show any symptom of osteoporosis. And the data would look something like this, what you see on your screen. It will have three columns and many rows. On the left, the leftmost column, you have the column for subject IDs. Then the measure of serum vitamin D. You would also have a column for calcium, which is not shown here. For each of, so these measures will be for each of the subjects. And then in the last column, mentioning if each of the subject had osteoporosis. This particular information is coded by zeros and ones, where 0 stands for absence and 1 for presence. In the sense, patients will be with osteoporosis and without osteoporosis, and for each of them there will be these different values. So people can take blood and measure those values from blood, and those values will be given in the dataset. Now, this is obviously that the dataset is truncated and it's a made up dataset. I made it up, and the real dataset would probably be hundreds of rows long. But the main point that is I'm trying to make from this data is that we'll need to find out from this dataset if there is a significant number of patients, they have a particular range of calcium or vitamin values. Let's also assume that the relationship would be linear, that is, the relationship between vitamin D and osteoporosis would be linear. So the first thing you would do when you have a data set like this, you would plot the data to see if you can fit a line through it. Once you have plotted the data, you would see a chart like what you see on your screen, where the x-axis would be something like serum vitamin D level or calcium level, and y-axis would be presence or absence of osteoporosis. So 0 in the near the bottom and 1 in the top. So this kind of response variable is called a binary because it can only have 0 or 1 response variables. Since it's a binary response variable, all the values would clump in these two neat lines, the top and the bottom, where you cannot fit a line. In other words, whenever you deal with a binary response, such as yes or no, presence or absence, 0 or 1, happy or sad, success or failures, etc., simple linear regression models do not make sense. In such cases, you would need to use a logistic regression. So let's explain what is logistic regression. It's essentially a regression model to study two sets of variables where dependent variables are known as binary variable, but also more generally any categorical response variable. Now, when I say dependent variable, they are also known as response variable. And the other set of variable that you need to deal with is independent variable. So rephrasing it, relationship between two sets of variable, one of them is independent variable and the other set is independent variable. In that case, the dependent variable has to be a binary variable. It has to be either 0 or 1, yes or no, success or failure, such that in such a case, if you need to understand the relationship between these sets of variables, you need to deal with regression model. But as I was saying, uh, the response variable can be any categorical variable. It does not necessarily need to be a binomial variable. It can be multinomial as well. Multinomial in the sense where it's not only yes and no, it can be yes, no, maybe. It can be multiple sets of disease, say diabetes, cardiac disease, and cancer. So each of these are categorical, but they are not binary. There can be multiple, multinomial. But for the purpose of this lecture, we would stick to binomial logistic regression, which is the simplest form of logistic regression. Just so you know that the independent variables can be continuous, categorical, or a mix of both. They don't need to be categorical for logistic regression. It's always based on the response variable. That needs to be categorical. So to sum it up, logistic regression is a special kind of linear regression models that can deal with binary responses. If you are curious about the bit where I call logistic regression model a special kind of linear regression model, do explore the generalized linear models because it's a special kind of generalized linear model. Generalized linear model encompasses both simple linear regression models and logistic regression models along with other linear models. Now on to performing a logistic regression model in R. You must have received presentations from other faculty who has demonstrated logistic regression in other software, mainly commercially available statistical software. But R is not commercially available software. It's not plug and play. You can't just put in data. Uh, but to understand and follow these demonstration, you'll need to have some basic understanding of R, and I would assume that you would have it, or you, if you're interested, you would need to explore that. And you can install R in your computer. In any case, I have given the link of the tutorial from where I have taken the example. It's on your screen. The tutorial has some more analysis than only the binomial logistic regression that I'm explaining here. So you can also, if you're interested, you can also go to the link and do those advanced analysis. As well as there are more advanced applications, visualizations, and exercises links are available on that link. So you can just do follow it if you are so inclined and you want to explore more other flavors of logistic regression or all the other ways you can explain the results. Let's get back to R. Just wanted to, if in case if you have never heard of R and don't know what it is a language and um, an environment for statistical computing and graphics. It provides a wide variety of statistical models, linear and non-linear modeling, classical statistical tests, of course, time series analysis, classification, clustering, GIS analysis, bioinformatics, and a large number of graphical techniques for visualizations. If you follow online newspapers, for example, BBC or CNN, you'll see beautiful graphics on them. Many of them are actually done through R. It is very popular among professional data analysts, only second to, I think, Python. Um, one of the reasons it is so popular is highly extensible. You can just add on to its functionality. There is no end to it, and there's a large number of people who do that. And also, it's open source. It's free. One of my favorite advantages is its reproducibility. So once you have the code ready, you can just run the same analysis again and again and again and again whenever you want. If you're publishing your results, you can attach that with the publication, so other people can also review your results without really getting bogged down with all the different steps. I can keep on talking about R. Instead, I have provided the link to our project here on your screen here, so you can, if you are curious, if you think it will be useful for you, you can go there and you can explore its functionality. In the following slides, I will introduce you to typical steps of an analysis in R. In this specific case, we'll be analyzing logistic regression, but I would like to point out that the steps that I describe in the following slides are the same for any analysis. It's not specific to regression analysis. That is again another useful thing about R or Python, where you can write script. You'd It's very easy to track them. It's very easy to trace all the different steps, unlike say in Excel, where it's often after some time you don't know what all different steps you had taken to come to a particular stage of your analysis. So if you are using R, it will typically look like this. This is R, but essence is actually R Studio, uh, which is an integrated development environment, or IDE. In simple words, it's an interface that helps you to interact with R. So you submit all your jobs. So on the left side, uh, you have the top left, you have a notepad where you can write your script, you can save them, and then you can initiate them. Once you submit those scripts commands to R, they will come to the bottom left one, and you'll see R response to that command, and you can follow those up. On the right side, on my right, you see the top, all the different data sets that you are incorporating, all the data sets that you are creating for your analysis, all will be there. You can easily go and click and see what all the data sets that you are creating. And then finally, on the right bottom corner, you have the visualizations that you will be creating, the graphs, the charts, and you can see them. You can also zoom them out, and you can see them being as a much broader frame, and you can save them from there. And and our graphics are very good. They are very professional looking, and there is no end to how interesting you can make them, and not that difficult to do. All right, so for our logistic regression analysis, to do the analysis, you will first need to install packages, which are collection of different functions to do different analysis, different jobs. For our example, for logistic regression analysis, you will need the main package with analysis functions called tidyverse. You will need to this to manipulate the data, to organize the data, to clean the data, to wrangle the data. These are different functionalities that you can do with data to finally make it ready to do your final analysis. And even the final analysis in specific case here for logistic regression, that functionality is also there in tidyverse. The second one is a package that includes a real life data from the US, from CDC, on osteoporosis and calcium and vitamin D data. And finally, you have ggplot2, which is a function which will help you to visualize your results with bar charts, with histograms, with bar plot, with anything, with line charts. So whatever you want, spatial graphics, everything is possible through ggplot2, only this one package. So the first step would be to prepare your dataset. You'll have a huge dataset. with tens and hundreds of variables like columns and thousands of rows. You don't need all these data for the current analysis. You would only need the 5 variables. Uh, so first you need to subset those variables from this huge data set. That is, you have to only collect those variables. There's a set of scripts available for that. If you go to that the tutorial link that I have provided, you will find them. I have not given those because those on the screen because those don't mean anything if you are not you have some knowledge of R, and also because it will not fit in the screen. But if you go to the tutorial page and if you want to try your hands on them, it's very easy. You can copy to your R screen, R script, and you can run them with the data and you'll see how it works. So once you have subset your data, the second thing you would need to do to organize your data in a specific way that makes sense for your analysis. In our specific in our specific case for the logistic regression, the vitamin D data is a continuous variable with a large range between 30 nanomole or here like 12 nanogram per ml to 50 nanogram per ml. So to understand the data, it's better to categorize this continuous variable into 3 classes, these 3 categories. Here it has been done from 12 nanogram is the deficiency. It has been called vitamin D deficiency, deficient, and then you have vitamin D inadequacy, which is 12 to 19 nanogram per ml, and then 20 to 50 nanogram per ml, which is called sufficient vitamin D. Once you have each of these category, you would like to see now in response to this category how the osteoporosis data is distributed. Final thing that you would possibly need to do with any data set is to find out if there are any missing data in your data, and usually they are marked as NA. um, and using the script that you see here on your screen, and also it is copied from the tutorial, you can actually find out the missing data, and you don't need to really bother about if you have found them, like if you have missed anything, the language will do it for you. So like R will do it for you, and it will take out all the data, it will remove all the data. Finally, in tidyverse package, you can use the GLM function to do logistic regression. And if you're wondering what this GLM stands for, it stands for generalized linear model on categorical variable. Because as I said, logistic regression is a subset of, is a special case of GLM. So you can use the GLM function directly on the categorical variable, and it will recognize the data and it will do it um, with little bit of scripting, with little bit of commands, it will just calculate. Once the analysis is over, you can use the summary function to get the results, which will look like this on your screen. That would be the output from R. But let's take a look at the results. And the result states that there is a significant association between vitamin D and osteoporosis. Those with sufficient levels of vitamin D in the blood have significantly lower risk of having osteoporosis. This result is highlighted with blue color and marked by 2 asterisks. The results also tell us that the inadequacy of vitamin D and serum calcium are not significantly associated with osteoporosis. So here it is. Doing logistic regression in R, the process is fairly simple and reproducible once one has mastered the basic steps. Here are some links for those who would like to explore further. The top ones are the huge online resources on R, as well as statistical computing or statistical analysis, modeling, etc., visualization. And the lower two are 2 books. One of them, the top one, is a new book and approaches statistical modeling from a Bayesian perspective. And the second one, the lower one, is a book which is a bit dated, but very nice and very simply it explains a lot of ideas uh, with examples from ecology. Uh, so if you are interested in to know more about logistic regression, more advanced stuff, as well as generally about statistical models and how R can make life so easy for professional scientists, do visit these links and try to get hold of these books. That will be all for this presentation. Thank you.